As a developer, you use SQL every single day. It is an essential part of your life. SQL is used at your job, at your personal projects, at hackathons, and whatnot. So it becomes essential to understand it at a deeper level, right? And in my case, there has always been this slight brain fog regarding some advanced concepts and advanced syntax that SQL has to offer. Like CTEs, window functions, how CTEs are different from subqueries, how subqueries behave in different contexts. I use all these things every day and it feels like magic at one point. So I don't like that and I wanted to close that confusion for good. So one day I decided to sit down and opened this LLM and gave it some stupid prompts and tried to understand every single corner of how SQL behaves and how these advanced topics work in behind the scenes and how the execution flow of SQL goes. And then after understanding these concepts, I went to LeetCode. I thought let's grind some LeetCode SQL. Even though I hate LeetCode, I thought let's grind these topics on LeetCode to understand how to make them behave practically and where to use them, where not to use them, and some more details about that. And that made me realize that you can literally learn SQL in a matter of days. Actually, learn at a very good level, and even become practically good in a single day. And it becomes extremely crucial for moments like interviews. When you have interview the next day and you want to prepare SQL and be actually good and show that you know SQL to your interviewer. I'm assuming that you have the absolute beginner knowledge of SQL because I'm not going to cover that, like things like select, update, delete, and all the basic syntax, because I'm going to focus on a bit higher level, a bit higher arc of SQL that you can use to target interviews. Once you understand basic SQL syntax and you understand basic SQL query writing like update, insert, select, the next big hop is to understanding subqueries. What are subqueries, how they work, and how they make our lives easier. So let's hop on to understanding subqueries first. Subqueries is like writing SQL within SQL statements. Or on a simpler note, we are trying to solve a smaller problem within a bigger problem. If we take a reference from the programming language we use every day, it's like using nested statements, nested if statements, or nested loops. We have subqueries in a similar way in SQL. So, if we want to take an example of why do we need subqueries in the first place, you can think of an example where, let's say we have a query that where we are trying to fetch all the users with a salary greater than 50,000. We can write a simple query for that with a hard-coded 50,000 value. That works. But what if we want to figure out a salary which is above average? We want to find out that all the employees with an above average salary, right? For that case, we need to use the aggregate function average, correct? And we need a subquery, a smaller problem that will resolve into a single value that is an average salary of all the employees within that table. And with that single value that we get out of the subquery, we can compare that particular scalar value with each and every row and figure out or generate all the rows that have above average salary, right? If I take an reference example of syntax, this is somewhat how we write a particular subquery. We have a main query at the very top. This is our main query, and then we have a subquery just below it. This is the subquery. Now what's happening exactly here, that we are trying to select some column name from a table name where we have a expression. This is a column name expression operator, and operator should have a right operand as well, right? So in this case we have the subquery as the right operand itself. Now let's take some examples to understand subqueries even better. So what I have here is an SQL editor, and this gives us some schema, a pre-built schema, and a few tables with some rows and columns. So yeah, let's hop on to the first example. Yeah, so we have this first example here where we are using a subquery. Let's focus on the main query first. Here we are trying to select all the all the items from the order table, all the columns basically. We are trying to select all the columns from the order table where the amount is greater than something. Now what is that something? Usually it should be a number, but here it is a subquery. Now the subquery returns a single value, a single average value of the whole orders table, calculating the average upon that amount field. Now when we calculate the average of the amount field in orders table, it basically returns a single value, and that single value is getting compared to this amount, which results in this particular row. So apparently this is the only row that is greater than the average of all the amounts in orders table. That's why we got this. But now this example that we have taken is like the most basic example for subqueries. Now let's move to something more complex and see how the context changes as per the queries. The context of subqueries keeps on changing as per the context of the query. So here's the second example that we are going to understand. So the second example says that we have a select query at the top which selects all the columns from customers. This time we have customers table here where the customer ID is in a particular subquery. Now when we use n, we expect a set of values, not a single value, right? So if you check the particular subquery, we are selecting multiple values. Select customer ID from orders where amount is greater than 300. That means we are selecting all the orders where the amount is greater than 300. That is this row, this one, and this one as well. So yeah, there will be multiple rows, right? And we are selecting a single column, that is customer ID. So we will be getting 4, 3, and 1. Hopefully that is the output. And then in the customers table, we are comparing the customer ID to these values and returning the rows that match these set of values. If I run the SQL, I get this output. As we can see, first, third, and fourth row is what we have got. First, second, and first, third, and fourth. Yeah, perfect. So this was a different kind of format for subqueries. Now let's hop on to the third kind of format that we use subqueries in. Here in this example, we are using subqueries with the from clause. So far the examples we've seen were where we used the subqueries with a where clause, right? It changes the context completely. Here we are expecting a set of values or a single value, right? A scalar quantity. But when we use it with from, it changes its context from a single value to a table. Now it is getting treated as a table rather than a set of values or a value. So here this generates all the status and customers from shipping table, which is here, and whatever is generated here, everything is selected by the main query. When I run the SQL, I'll get these two columns with all the rows as I expected. We got status and customer as I selected in the subquery, and we selected all in the main query, so we got everything. Now about the next subquery example. Now this is a bit more complicated. Here we are selecting pair of columns rather than a single value or a set of values. We are selecting multiple values and multiple columns as well, and comparing them as well. So as you can see, we are comparing the amount and customer ID from orders table to the maximum amount and its customer ID within a subquery, right? Here I'm using group by and having, although this is the focus for the next topic, but for now just ignore this and understand that we are trying to group these rows by customer ID and getting the maximum amount among them. So yeah, if I run this particular SQL query, I get this one output. Now here, as you can see, the condition I've set that the count of customer ID should be greater than 1, and there is only a single customer ID where the count is greater than 1. So we got this particular row with the maximum amount, which is 400 among these two. Now this subquery returns two columns. First is the maximum amount and the customer ID, which gets compared to this amount and customer ID. The focus here should be at the subquery rather than the complications that are present in the subquery. Yeah, so that is all about the basics of subqueries, how to use them, how it behaves in different contexts. So the next important thing that you should study right after subqueries is group by and having clause. To understand group by and having, let's take an example. Imagine having a customers table where each customer belongs to a specific country. Alright, so now there is a problem statement that states that we need to count the number of customers belonging to each country. Now how can you solve that just using SQL? To do that, we can take help from group by. What we can do is group all the countries together and within each group of these countries there must be some rows, right? They will group all the countries together and bind all the rows associated with that group to that bucket that we created. And when we apply this count function over each group, it will get the count of each country that we have. Now that is something group by allows us to do, and along with having it becomes much more powerful, but we'll see that later. For now, let's just focus on group by. Now, yeah, let's hop on to an example to see this in action. Here, let's take example from this customer table as we have it. We'll just copy this whole thing, yeah, and bring it to our XL draw. Yeah, here we are. I'll just remove the header so it becomes less messy. Now, with this table we have each row has a customer detail and associated to a country. So if we let's say apply group by here, we say group by country. Now what happens when we write this specific statement? It basically groups all the countries together into a bucket, and each bucket contains all the data. Just like imagine like a hash map, or maybe in JavaScript we have objects, and in Python we have dictionary. Imagine a similar kind of data structure that gets created in the background. So let's take an example, like let's simply create a diagram showing the buckets. So first bucket becomes USA, then the second bucket becomes UK, and the third one becomes UAE, right? So wait a second, UAE, yeah, that's perfect. So yeah, when we apply group by over countries, it groups all these countries together into 3 buckets, or if there are more countries, it will make more such buckets. And for now we just have USA, UK, and UAE, right? So what happens within these buckets? Each bucket contains all the rows associated with the country USA. So we can say this is a key, and the associated values are a set of rows. And what are those set of rows? In USA's case, we can say these are the rows. Let me just copy these 2 rows, and yeah. So in this bucket, you'll have these 2 rows specifically, because these are associated with USA, right? And in a similar fashion, we'll have for UK and UAE as well. So we'll have something similar. Let me just copy paste to replicate it. Yeah. So we have this bucket for UK, and in this UK bucket, similarly the rows associated with the UK will exist. Perfect. Now these buckets come with some predefined operations that you can perform on them. Like if you group by country and try to select the country, it will get you all the different countries. As simple as that. But if you try to get the count of these rows, it will simply count the number of rows in each bucket and give it out to you. Similarly for UK and UAE. So let's see this in practical. I'll write a similar query. We'll write select. We'll select something from the customers table as C. Now let's group by C dot country. We're grouping by country, and we'll just say country. So give me all the countries. Yeah, so if you see the output, we got all the different countries listed down. Although there are multiple duplicates, but it just gave us each country only once. That is because each country is associated with a bucket now. Perfect. Now let's say we want to know the count of rows that each bucket contains. We can do count star maybe, or we can even write country as well. Let's write country, C dot country, and here should be C dot country. And if I try to run it, I'll get 1 2 2. Because UAE only has a single entry, and USA has 2 entries, and UK also has 2 entries. So as I told you in this particular example, we created 3 different buckets by grouping by country, and each bucket had its own rows, and we can perform some operations over them. For example, count. And let's do something more with it. Now let's give it an alias first of all. What is an alias? Alias is a simpler name for some column that we want to give. Let's say we call this country count. Okay, when we run it, now the column becomes country count. Perfect. Now we'll just do an order by country count descending. So this will order it by country count in a descending order. So the larger count will come at the top. When I run the SQL, as you can see, it is inverted now. USA is at the top, UK below it, and UAE at the bottom because it has the lowest count. Now let's take it a step further and try to select a different field. Let's say we want to select the first name. And when I try to select the first name, what do you think will happen? Because in the current state, when we group by country, there are 3 different buckets of countries, and within each bucket there are multiple rows. And now when we try to select the first name, it does not know what the first name is, because within each bucket there are multiple rows, and for each row there is a different first name. So it does not know which first name to give it to us for that particular bucket, right? Because we have grouped it together. Now this is the main supplier of the data. Now when we try to fetch the first name, it does not know which first name to give us because there are multiple. So if I try to run the SQL, let's see what happens. See, so we did get first name, and we don't have an error. But the output we got, we don't know the order, right? Let's try to understand this. So for USA we got John. If you look at the original table, the first row associated with USA is John, and that's what we got. And for the UK we have David as the first row, and that's what we get. And for UAE it's Betty. Now, so we do understand that it just picks the first row, but it is usually not recommended in production scenarios, because we don't know the ordering or the format it will give us the output in. So we rather not do such kind of selections. But if we really want to select the first name, we'll have to add that to group by as well. But now if we try to group by country as well as first name, the whole state of these buckets change. Now these buckets will be splitted even further. Now let's see how. If I try to let me replicate this whole bucket here. Now it won't just be USA, it will be USA associated with a name as well. Let's say the first bucket becomes USA comma John, because we selected the first name. And similarly there will be a second bucket where USA also contains Robert, because that's the second row, right? So it will split those buckets even further into the combinations of country with the first name. So there will be approximately 5 buckets, because USA has 2 rows, UK has 2 rows, and UAE just has 1 row. So it will create 5 buckets overall. And let's see, if we try to run this, what output do we get? See, for the country count we just got 1. Why is so? Because now within each bucket there is only a single row, because for a country and first name combination there will only be a single row according to the data set that we have. So that's why the country count is 1. And now it is not actually the country count, rather the bucket count. And for the first name we got all of the first names associated with the countries. Now that's how group by really works. Now let's try to understand why we need the having clause in the first place. So for now the things have been quite straightforward, right? Now let me just simply remove some statements here so I can make space for the new example. Yeah, so we are here, right? So now in this example we are grouping countries and printing country counts, and it's pretty simple, right? So far it has been simple. Now let's introduce something, some condition here, that we only want those countries having the country count greater than 2. Can we do that? Let's see. So we want the country count to be greater than 2. How can we do that? Let's we know that we have something called where clause, where we can add an expression and filter by that condition, right? So let's add an expression saying we need the count of country to be greater than 1, so that we'll only get those countries with the count greater than 1. So I'm expecting UK and USA. So if I try to run this, we got an error, and the error says misuse of aggregate count. Now this was supposed to happen because if you try to Google it, where does not support aggregate functions, and where is therefore simple filtering, filtering over basic rows and basic logic, right? It does not support aggregate calculations and aggregate filtering. So what do we do now? So for that exact reason we have something called as having. Now what is having clause? You can imagine having as the where clause for groups, where when we use the where clause, we use it for filtering simple SQL queries, right? But when we add grouping to the SQL query, then we need to use having. So having is something that supports aggregate functions as well. So if I try to do the same thing here, exact same expression I've written with having clause, when I try to run this, it works just as expected. We wanted UK and USA because the country count is greater than 1, and we have it. Perfect. But that makes us skeptical that can we still use where clause along with groups? Yeah, definitely we can, because where is something that helps us with filtering. Although we can't apply aggregate filtering, but we can still use some simple filtering. For example, if we want to hardcode the country to let's say UK, okay, if we try to do this and if I try to run it, we'll only and only get UK, because we have applied a condition saying that the country must be UK, and then we apply the further grouping and then we count and we get this as the output. Now if I try to change this from UK to UAE, I will get this, that the SQL query has successfully executed. However, the result set is empty. That means there is no country called UAE with rows with the row count greater than 2. Because that's as per the given data set here, that it matches the exact scenario and gives us nothing, because there is no such condition that fulfills, right? So that is how and why we need having in our SQL queries. And having is something we usually use with group by to support filtering over aggregate functions. That's all you need to understand. Now, to drop the confusion even further, let's move a step further and understand how a typical SQL query executes. What is the SQL execution flow? So that when you write SQL query, you have a deeper understanding as of what execute first and what happens next and what happens after that, so that it does not get confusing. So the typical execution flow for a SQL query goes like, first the from clause is executed. So from, let's say, customers, when we write this statement, it basically gets the customers table from data store and brings it to the memory of the server. Now the from clause is what gets executed at the top level. Then follows joins. Now joins will join basically the other tables, and we again bring it from the storage to memory. So, and if you don't know anything about joins, it is the most basic thing and you should be knowing it, because it is really important for interviews. And learning at the very basic level what inner joins and left joins are and how they work is really crucial, and that should cover most of the use cases. So at least be familiar with inner and left join. Assuming that you know what inner and left join are, I am going to proceed. So what these joins do is get all the other tables to the memory. So first from is executed, then join is executed along with a condition. Let's say c dot customer id is equals o dot customer id. Yeah, that is something that will join both these tables. So customer tables is brought to the picture, order table is brought to the picture. Now what? Then follows a condition. Yes, just right after the selections happen of the tables are brought to the memory. This filtering happens over those tables. Let's say we want to filter by age 22. So when the tables are brought to the memory, it gets filtered by age. Age is greater than 22. Only those rows are filtered. And right after that follows group by. Yes, and we still have not brought select into the picture, because that's how SQL execution goes, after where groups are created. Yes, so let's group by country again. Let's keep things simple and group by country. So yeah, right after grouping happens, the having clause gets executed. Having, we'll take the similar statement dot country where it's greater than 1. Yeah, perfect. So the tables get brought to the memory, filtering happens, grouping happens, and filtering upon that groups happen. Perfect. And once everything is done, now we bring select to the picture. Yes, before that select is not something that gets executed. This is the typical flow as I went by each and every clause. Now select is one of the last priorities in an SQL query. So now the selection will happen. So we'll select the count. Let's call it C count, and then that we should get the country as well. Yeah, perfect. So after fetching the tables, we filtered, we grouped, and we filtered those groups, and we selected the count and country. Perfect. So far everything's going great. Now if I try to run the query so far, let's see what happens. We got UK and 2. Great. Now let's see what happens when we apply order by. Yes, order by happens right after select. So we can do order by, let's say, C count and descending order. It won't change anything because again we have only a single row, but right after select the ordering happens, and that's why we were able to use this alias right here. And you can't really use alias anywhere else in the query, because this is the typical execution flow, and after selection ordering happens over that data, and that's why you are able to use aliases in order by and not anywhere else. And this can turn out to be an interview question as well. So after ordering, the last thing that happens is limits and offsets. Now if you want to limit the number of rows, you can use limits. So if I do limit 1, it won't actually do anything because there's only a single row. I can do limit 0, and let's see, we got an empty set. That's because I've set the limit to 0. This is the last thing that happens during the SQL query. Limit execute at the last moment. Now let's talk about where do subqueries trigger. Well, that depends again on the context of the query. If I try to write subquery in a where clause or in the from clause. Now if I typically write from clause, it will get executed at the topmost level, because right now we are trying to fetch the tables into the memory, right? So it creates a table out of that subquery, and if we use it at where, it happens after the joins that follow. Perfect. So this is how a typical SQL query flow goes. Now this is something that you must know, because that clears 50% of the confusion that people have with SQL. Now before proceeding any further, we should actually go to LeetCode and solve a few patterns to understand how these clauses or clauses and statements apply to real world scenarios, to understand the practicality of everything we learned so far. So yeah, let's hop on to LeetCode and do some problems. Okay, so now I have with me a few LeetCode questions. So let's apply whatever we have learned so far. So we have been given this person table schema where we have an ID, we have an email, and ID is the primary key, and there's a constraint that the emails will not contain any uppercase letters. That will make our problem a little easier. Now we need to write a solution to report all the duplicate emails. Now this is a real production scenario that might happen, due to some bug there might be some multiple duplicate rows that have been created in the database. Okay, so how can you resolve that? Now let's try to figure this out. How can we write a SQL query to report all the duplicate emails? Okay, so we also have an example here that we have a person table with a few IDs and emails, where this particular email is appearing 2 times. That means it's a duplicate email, and we need to report this. Now the output should look something like this: email column name and with the duplicate emails. Perfect. Now let's think about how can we write a SQL query to get this specific output. So as we were talking about this execution flow, so we know that we need to select something from the persons table. Let's call it P. Okay, and now do we have a condition here? Yeah, we do have a condition that we need duplicate emails. And what does duplicate mean? Meaning we can say in a simpler way that the count is more than 1, right? If you want to know that the count, we need to filter all the items that have count more than 1. We need to basically apply an aggregate function, right? We can do something like count p dot email is greater than 1. That is it, right? So as I told you, we can't use where, because that will result in an error. Okay, yeah, that will result in an error, of course. So we'll have to use having instead, and if we are using having, we must use group by. And what are we going to group by? Again, email, because that is what duplicate items we have, right? This will group all the duplicate items together into a single unit with multiple rows, and then we can easily evaluate the count. Perfect. Now we need to select all these emails. So I'll write select p dot email as email, right? Because we have this output format, I need to adhere to it, otherwise it'll throw errors. So yeah, select email from person, group by email. So let's try to run it and see what happens. As you can see, the first test case has been passed. Let's try to submit it. Yeah, so we easily solved the problem using all the basic knowledge we had about SQL. So perfect. Now let's head on to the next problem. Now the next problem is customer who never order. Okay, customers who never order. It is again an easy question, and we have been given a schema called customers, where ID is again the primary key, and each row of this table indicates the ID and name of the customer. Okay, we have a name. Perfect. So we also have a different table this time called orders, where we have a foreign key, I believe, which is customer ID. ID is the primary key and customer ID is a foreign key. Perfect. Of the ID from customer table. So this refers to this ID. Perfect. Now what is the problem? Write a solution to find all the customers who never order anything. Okay, return the result table in any order. Result format is in the following example. Okay, so you can look at the input. We have been given the customers table and the orders table, and the expected output is customers, where we have the customer names with those who haven't ordered anything. Now how can we go about doing something similar? Okay, let's think about it. First of all, we know for sure that we need customers table, right? So we'll do customer C, and we'll do a join with orders table O, and the condition says that C dot ID should be equal to O dot customer ID. Yeah, perfect. So far we have combined both the tables, right? So now let's look at what needs to be done next. Yeah, now let's apply some filtering, right? So actually, should we even use a simple join? We can make the whole problem simpler just by using left joins. How? Like what left join does is it joins both the tables, giving priority to the left table, and if the right table does not have an entry for left table, it will give us null. So let's say if a customer hasn't ever ordered anything, we'll just get a null, and we just have to filter out that null, and we'll get our output. So we can simply apply a filtering here because this is a simple where clause where o.id is null. Yeah, I guess that should do it. And let's select what we need to select. We need the customer name, so we can do c dot name as customers because that's the constraint they gave us. Okay, now let's see if this works. Yeah, the test case was submitted properly, and now let's try to submit the solution as well. Okay, awesome. So the problem actually worked with this format. What we did here was just basically filter out the null. We combined order and customer table together, and for the customers who have no orders, we did a left join, so we get a null on the right, and we simply filtered out wherever the order ID is null, and we got our customers. That's it. And okay, let's now hop on to a different problem. Okay, now let's head on to the next one. So the next problem is called second highest salary. Here we have an employee table with a primary key as ID and a salary field. And the problem says write a solution to find the highest distinct salary. The second highest distinct salary from the employee table. If there is no second highest salary, return null. Okay, so let's think about it. First of all, in the similar format as before, we start from and we select the employee table as E. Okay, since there is no other table, we don't need a join for now. What can we do here? Let's think about it. We need the second highest salary, right? So we can maybe apply an order by, right? Order by on employee dot salary in descending order. If we invert the table, we'll get the highest salary at top, second highest at the second point, and and further it follows the lower order, right? So now this won't still solve the problem because we have the first salary at the top, and we want just the second highest, nothing after it, nothing before it, right? So we can take help from limits and offsets as we talked about it. So we can limit this to just one output, and that will just give us the top element, right? And if we use an offset also, offset of 1, that will skip the first row and directly give us the second row. Now if we just do something like select, what do we need to select? We need to select the second highest salary, right? So let's do select e dot salary as second highest salary. Okay, let's try to run it. So what went wrong exactly? So the desired output format expects null if there is no row available, and what we are returning is just an empty answer, right? So how to fix that? So there is this SQL trick that we can use by wrapping it around as an subquery. Oh, I actually missed something. I should have used distinct here because the problem demands so that we need distinct highest salaries. A distinct highest means that we need all the unique salaries. We don't need duplicates. If there are multiple second highest salaries, it will list out all of them. But we don't need that. We need a single highest salary, right? So that's why we need distinct. Okay, back to the null issue. Yeah, so I wrapped it in a subquery, and let's do something like I'll do select here. Select this as the answer we need. Actually, I should just trim it down and do something like this. Yeah, now if I try to run it, I'll get, yeah, it worked. See, in my output I also have null. But how does that really work? So whenever the inner subquery returns an empty answer set, the outer query automatically turns it into null if we use this particular SQL format. So these small tips and tricks are things that you learn while doing while hopping onto LeetCode and doing these problems. These are the patterns you need to know. and these are crucial for the interviews as well. So now if I try to submit this particular problem, it got accepted, and yeah, it works just as expected. So I usually recommend people to hop onto the Solutions tab to look for more approaches to solve the same problem. Look at how other people have solved this particular problem. So let's hop onto the Solutions tab and look through some solutions. Let's just check out this one. And there are different methods listed. So the first method is similar to what we have done. Actually, it is literally the same. So if we move check out the second method, it says says to use max with a subquery. Yeah, we can do that. Let's try to solve it ourselves. So if I try to do something similar, let's go the other way, the execution format way. If I try to select employee as E, where the E dot salary is lesser than the something, let's talk about the something later. And yeah, I don't think we need limits. So yeah, let's come to the subquery. We select the maximum salary from employee table. Yeah, that is it. So this will give out a scalar value. It will check the whole table for the maximum salary and give it out as the output of the subquery. So we have a scalar which we are comparing to our current salary, that is E dot salary, which should be less than this subquery. So what will happen is it will create an in-memory table for all those values in the employee table where each salary is lesser than the maximum one. So now we can try to select it. Select E dot salary. Actually, not just E dot salary. We need to select the maximum out of those E dot salaries as second highest salary, right? So if I try to run it, let's see what happens. Okay, so we are getting null for some reason. Let's look at what's happening. So we are trying to select the maximum salary as second highest salary, employee less than this and this. Yeah, I guess if I is there any salary lesser than the highest salary? The highest salary should be 300, right? Let's try to debug this. If I try to write something like max of salary from employee table E, and let's try to run just this. I hope we get 300. Yeah, we got 300. And if we wrap this into a subquery and do something like yeah, so we can do select over that and get the maximum salary from employee E, where the E dot salary should be lesser than whatever the subquery returns, because that will be our second highest salary, right? So if I run it, what is going on? Okay, this time everything worked as expected. We just need to use this and this shall work. Yeah, it worked. I don't know what was happening before this. So if I try to submit it now, I think we'll get our output. Yeah, it again got submitted. So if we look at the solution that the guy had to offer, so yeah, it is just the same. It selected salary, a second highest salary from employee, and the salary should be less than the subquery, the max highest salary. Yeah, just like that we can apply different approaches. Now there is another approach. If we look at it, it uses this complicated query, which is actually known as a window function, which we'll talk about later in the video. So for now, let's skip this solution and we'll come back to this later. Now let's try to understand the next concept we should study right after this, and that would be understanding CTEs. Okay, now let's try to understand what CTEs are. So CTEs, yeah, CTEs is one of the most underrated topics in SQL. Not many people learn it, but it is extremely useful, makes you stand out in interviews, and makes your lives really easier if you write messy queries every day. Because if you write huge queries and which get a lot messy, CTEs is the way to go, and it will really make your lives easier. So CTEs refers to common table expression. Now that isn't really helpful to understand what CTEs really are. Assume that you are creating blocks of SQL. that you can reuse again and again in different subqueries. Just like you use variables and functions in programming, CTEs is one of the ways to go about it. So let's take an example. Just like we did in select highest queries problem, we wrote a select statement as highest, right? So in that particular statement, we had something like, select distinct salary from employee. I don't know why I do this always. Yeah. Not where, order by e dot salary and descending order, limit 1, offset is also 1. So yeah, so we wrote this particular query, which first of all resolves the internal query, the subquery, and then gives out the result. For making this subquery reusable, we can convert it into a CTE to make it a lot simpler to use and reusable everywhere. How can we do that? So let's first understand how the CTE syntax works. So we can write something like with our CTE name. It could be anything. CTE name as the columns. I mean the query that will go here. I'll just copy this subquery from this one, and you can just move it here. Now we have a properly working CTE. Now if you want to use multiple CTEs together, you can just use a comma and write CTE second as something else. Now this will become another reusable CTE. You can also you also have a support to export only specific columns by using column 1 and column 2. You can explicitly specify all the columns that you want to export from the CTE. So how do we use it in the existing query that we have? So what we can do is, instead of writing whole this mess, we can just use something like select salary from our CTE name, whatever it is, CTE name, and it should probably work. Now let's just go back to the LeetCode problem and try to implement this with the CTE. And let's write a CTE here. So we'll write something like my CTE, okay, as the same query that we actually, why not just copy the text from here? No, sorry, let's copy it from here and not make our lives any more difficult. So yeah, this is the query. We select distinct e salaries from employee, order by this and this. Yeah, perfect. So now we can further do the select statement just under that. Select select e dot let's just write salary from my CTE. That's it, as the second highest salary, and that should give us a desired output. Yeah, perfect. It works just as expected. So if I try to submit this, it works just fine. Now the problem that I usually had with working with CTEs is I never really understood the difference when using CTEs and when using subqueries. I mean, can we use it interchangeably at all times? Actually, we can't. Just like in this situation, I could have just wrote my CTE here and expected it to work, but it does not work like that. And why is so? As you can see, it returned a runtime error saying unknown column my CTE in field list. So that makes us come to a conclusion that whenever we write a CTE, it actually returns a set of columns, a whole table. Even if it is just a single value, it is going to return. It does not matter. It usually returns a column, or a whole table from CTE. Whereas in subqueries, as I told you, it depends on the context. It might return a single scalar, multiple scalars, or multi-column scalars, like a tuple or something. But with CTEs, it gives out a whole table, even if it is a single value. That's the major difference while using CTEs and subqueries interchangeably. That's why this particular example didn't work, while what we had earlier, this works like a charm. Now that we are done with CTEs, now let's study about something simpler. Although it is very simple, but it is extremely useful in practical scenarios as well as interviews. So we are going to talk about case-when statements. It is just like if-else of SQL. Just like we write if-else or switch case statements in programming languages like Python or JavaScript or Golang, whatever. Similarly, we have case and when statements in SQL. Let's take an example. For now, let's use the customers table. and we'll select C dot star. When I run this, yeah, everything works just fine. So now let's come to our case and when statements. It typically starts with a case statement and an end statement, that is like to end this particular case, and we'll write an alias for this to output. Let's say we need to print the presidents of each country for some reason. We don't have the president data here, but let's take an example. So we'll just write president like that. Now inside this case and end clause, we'll write something like when. Okay, when is the if of these case and end statements? When the c dot country equals USA, then we can say Donald Trump. Perfect. And now when this is going to be the else if statement kind of thing within the case clause. So I'll do that again. Country equals UK, then I don't know who's the current PM, so I'll just write Rishi Sunak for now. Rishi Sunak. And then we have else for every other statement. We'll just write I don't know. Okay, so we have a case clause and it is closed by end, and we gave it a alias called president. Now in the case clause we have when statement, where we defined a condition. If that is true, then this will happen. If this is true, then this will happen. Else just it will just show I don't know in the president column. So let's try to run the SQL and see this in action. Yeah, so you can see the output right here. So it has added a president column to the table, although there is no president column present in the customers table, and it adds the president names to the table. So for USA we have Donald Trump, USA Donald Trump, UK Rishi Sunak, and for UAE I don't know. Okay, so this is how case and when statements work. They are extremely handy and extremely useful in practical scenarios, as well as your interview situations for LeetCode problems. So as we are at it, let's as well understand a few more similar things to case and when. We have something called if null. Now what is if null? It is something it is a function that SQL provides us to make things simpler. If anything comes out to be null, if we have a null value, we can just replace that. Let's say if our country is null for any particular situation, we can just have a column saying let's call it no country. Yeah, if there is no country available, we can just say no country, else it will give out country. Yeah, if I run this again, you can see I just got all the countries, as we have all the countries available. If any one of the countries turned out to be null, it just would have said no country. That's it. Now this comes in handy as well, so I thought why not just cover it. Another similar function to if null is something known as COALESCE. I don't know how to pronounce or even spell it. Let me Google search it. Yeah, so we have COALESCE in MySQL. Now what is this COALESCE? It is something similar to if null, except it can take multiple values. So let's say we have multiple countries, for example. I'm not actually going to execute it because it is not that heavily used, but you should at least know it, that we have multiple let's say countries, and even if this one is null, it will return the next adjacent to the null one. If that is also null, it will go to the next one, and if everything is null, it will simply return null. That is what COALESCE does. That's all. And no need to bother about it. If you want, you can check out some examples online and maybe practice some on LeetCode, and that will be more than enough for COALESCE and if null statements. Now let's address the elephant in the room and talk about window functions. So window functions is a topic that makes SQL actually interesting. I personally use it a lot, and it almost looks like magic happening in SQL until you don't understand it at a deeper level. Now, what is window functions and why do we really need it? So we know something that we talked about before. That is, we talked about group by queries and having, right? When we do group by on country, maybe, so at that moment it creates bucket for each country, just like we talked about in the previous example, right? Now, what if we want to perform some calculations over these groups that we create, but instead of shrinking or losing the data, like when we group the data, we get groups, but we don't get the data intact. We don't keep the data intact when we group them together, right? So if we don't want to lose our data and still perform the calculation over the groups, how can we do that? That's something window functions allow us to do. Now the typical syntax goes like, we write a select query, we apply a aggregate function, let's call it func for now, it could be anything, count, sum, or whatever. We apply it over a certain number of rows or a certain partition of rows, and then the rest of query follows. So with this syntax, we can perform calculation over a set of rows and without ever needing to group it. Okay, now let's see an example in action. If I do something similar, we'll select something from, let's say, customers only. We do select something from customers. Now what is this something going to be? Let's say we want to count something based on the countries. We want the count of each country, just as we did with the group by in the earlier example. We'll do something similar, but this time I'm not going to without doing group by. I'll try to do it with window functions. So if I try to do something like this, count star over everything, when I just specify over, it takes assumes it as everything. We don't have a logic specification inside over, so it does not know over what. It will perform over all the tables. So when I run it, it will give me the count. So as you can see, it gave me 5 5 5 5 5. At the first look, you don't really get it what it's trying to say. Let's make it simpler. We'll call it as count. We'll call it count, and we'll also specify star. Now, one of the disadvantages of using groups is that we can only select those items that have been grouped together. Just as we saw in the example, we grouped countries and names together. So we had to we could use them in select, but we can't use other fields in select if we haven't grouped them, right? That is not the case with window functions. You can use them along with all the fields available to us. Now, if I try to run the SQL, you will see an amazing result that we got all the rows, we have everything intact, and we get a new field called count with the value of 5 5 5 5. Now what is this 5? What is actually going on? This can get confusing, so let's try to understand what's going on. So it basically we haven't specified any constraints, so this over makes sure that it counts all the rows in the table. There are in total 5 rows, 1 2 3 4 5, and that's what the count what we get stored in this count variable. So once you calculate the count, it just populates it for each and every row, the same answer. That is why these window functions get in handy. Now let's see. Let's say if we want to count by country, just as we did with the group by example, I can, instead of using group by, I can use something like partition by. Partition by, we can say c dot country. Now what it will do is that it will split all these rows into by the country names, and when it splits, it will count it, and it will append those particular rows with the exact values that we need. If I run the SQL, as you can see the results, for the UAE we got count as 1, for the UK we got count as 2 because there are 2 rows, and in the other row as well we got 2. For USA we got 2, for the other row of USA we also got 2. So I hope this is making sense to you, that we are basically virtually splitting this whole table into certain groups and performing calculations over them, and meanwhile the data of the actual tables remains intact. We just append a new column to it, and for all the rows in the table it populates some value. So now that we are familiar with window functions, how to use them with aggregate functions, and what is partitioning, now let's go a little further and understand something even more. Let's talk about more functions actually. I'll talk about row numbers first. So row number, we can't use partition here actually. I'll show you why later, but for now let's just keep things simple. I use row number over every row in the table, and as now when I run the SQL, I get 1 2 3 4 5, and yeah, it just basically gave each row a row number. That's it. That's the whole logic behind row numbers. Now let's do something more interesting. We can use order by here. Yeah, these window functions support order by. and we can order by descending, or let's say ascending. It's already in descending order, so no, it's not in descending order. So let's do c dot age in descending order, and when I run SQL, so you can see now the row numbers are according to the inverted ages. So now the age is in the descending order, and we have some row numbers assigned to each one of the row. Awesome. Now there is a similar thing called rank. Now if I run SQL again, you can see that now we have some rankings done over these rows. Now how do these rank really work? So when we try to assign rank, it goes over to each one of the row, and it ranks the similar kind of rows with the same value. That's what rank does. Like in when you check ages, 31 is a different row, 28 is a different row, so they get 1 and 2. 25 is again a different row, it gets 3. But 22 and 22, they are both the same numbers, right? For now we are ordering by age, so focus on the age column here. So each one of the different row got 1 2 3, but when it came to the same rows, it just gave them the same numbers. All right. Now let's try to do something. Let's change this from descending to ascending. Now when I run SQL, you'll see something crazy. That now the rank that has been assigned to each one of the row is in ascending order of the ages, right? 22 comes at the top, 25, 28, 31. But the weird thing is that we got 1, 1, then 3, 4, and 5. There is no 2. 2 is missing. So what rank does is, it will skip a number if there are duplicates. So there are two duplicate ages for 22, so it gave them the same rank, but it skipped the next consecutive number, rather got to the next in the iteration. And if you don't want this and you want a consecutive order of numbers, you can use something called as dense rank instead of rank. Now when I run this same SQL, you will see that the same numbers get the same ranks, but you get the consecutive number after that, not a it won't really skip the numbers in between. That's the advantage of dense rank over rank. That's it. That's the difference. Now we can also do this with partitioning. If I do the same partition by c dot country as we had done before, and I still keep on applying the dense rank at order by, and I run this SQL, you'll see that this happened again. It changed the ordering. This time it's just rank actually. So within each country, within each country block, for each different age, it will assign a different number. So you will see that within UAE country, there is only a single row, that is 28 age. It will assign it 1. But for UK, there are 2 rows, right? There is one is 22 and the other is 25. Here we are partitioning by country, so you have to focus on country as well as the age. So we have splitted the whole table into different blocks by country. So UAE is a different block, UK is a different block, and USA is a different block. Now within that partitions, we are applying an order by field to rearrange the ages, and then we apply dense rank over those partitions. So within each partition, it gives a different it restarts the rank assignment logic. So for each different country, it restarts from 1 again. For UAE 1, then we got UK for 1, UK 2, and then for USA we got again 1, and USA for 2. Now let's take some examples with this orders table. I'll just use the orders table this time, orders O, and I'll just remove all of it. Now within that this SQL query, I can do something like sum amount over as total. I mean, if I run this, we got my bad. So yeah, now if you see what is happening here is, it takes the whole table, sums up all the amounts, and appends that to each one of the entries in the table with a new column named total. Perfect. Now let's apply a partition by let's say keyboard. We can do by keyboard, partition by keyboard, sorry, partition by item. Now when I run it, you can see we got the total, and this time as per the item. For each different item, we have created different partitions for each different item and calculated sum within that particular partition and appended to the main table. there is only one item that is duplicated twice, that is keyboard, and the keyboard costs 400 for each time, so that adds up to 800, and that is what we got in total. And monitor is only, there is only a single monitor, that is 12,000, mouse and mousepad, that works normally. So yeah, this is how you can use sum. Now there are some more operations that you can perform over window functions, like we have something known as lead. Let's do one thing. I'll remove the partition again and I'll run the SQL. Now you can notice something, that we have applied something called as lead. Now what does lead do? Now lead is applied to, first of all, lead is applied to amounts field in the table. Now lead takes the next the adjacent row to the current row. Let's say we are on keyboard, it takes the adjacent row, that is mouse. It will take the amount from mouse and put that in at the at the same level as the current row. So for keyboard, it took the amount from mouse and added that to total. For mouse, it took the amount from 12,000 and added that to total, and that is what happens. So for the last element, that is mousepad, there is no next element, so it is just null. It should be null, but it is just empty for some reason. It is actually null here. So similarly, we also have something called as lag. If we run lag, we'll get a similar output. This time, instead of taking the next amount, it takes the previous amount, and the first item remains null because there is nothing before that, so it keeps the total as null. So that is lead and lag. That also comes in handy when solving problems, and it can be used in your daily work or your projects, depending on the use cases. Now that we understand the basics around these window functions, I think we should practice some of them on LeetCode and get a practical understanding of how to use them. So here I have with me two SQL questions from LeetCode, which covers the window functions that we have studied so far. So let's see how to implement these window functions in a practical scenario. So here the problem says we need to find all the numbers that appear at least 3 times consecutively, and we need to return the table in any order, and the result format is in the following example. Okay, so we have a logs table with an id and num column, so we have to return the consecutive numbers. So this is going to be, these are going to be distinct consecutive numbers that we have to return, as per my understanding. The table is logs, and where the id is the primary key and auto increment column. Yeah, that's the basic stuff. So yeah, the problem basically is we need to return all the numbers that are consecutively appearing more than one time, more than at least 3 times. So yeah, let's see how can we go about writing such a query. So here the obvious thing that comes to your mind is lead and lag that we just talked about, how we can check the consecutive values, right, in lead and lag. So how can we do it? So let's say we select something from logs as L, right? So we need the L.num itself, the number itself. We need the lead of L.num over the whole table as first. Let's call it first. And we need the second consecutive lead. How can we get that? So we can do something like 2. So what does that do is it gives you the second lead, that is one after the after skipping one, whatever lead we get, that's a second consecutive lead. So when I apply over as second, okay, let's call it second, like that. Let's call it as first, second, and yeah. Now if I try to run this, it will probably lead to some error, but we'll at least get to see what we are getting. So yeah, this is the table we are forming. There is num, there is first, and there is second. For num, we are getting the first lead, that is this one for this, and the second lead, that is again 1. Now for the second item, we get 1 1 2, that is the first lead is 1 and the second lead is 2, so that's why we got 1 and 2. And for the third one, similarly, we got 2 and 1, that is 2 and 1. For this 2, we got 1 and 2, that is again 1 and 2. So it's in that fashion we got all the first and second leads of, that's how we get the first 3 consecutive numbers. But that is not enough to solve the problem, right? We need to wrap it inside a subquery. If we do something like okay, we need to format it. Yeah, now when I do some selections from this particular subquery, I'll use it as a table and write something like this. We need dot num as whatever this name is, consecutive nums, but we also have to apply a particular condition saying that where the l dot num equals l dot frst, that is the first one, and l dot num equals l dot scnd second. Yeah, so wherever the num the first and the second match, we know that it is a consecutive consecutive flow of numbers, and we can simply return that. If I try to run this, yeah, it did work. It works just as expected. I took the first number, took the first lead and the second lead and compared them over using a subquery, and that's how I got my consecutive numbers. But when I try to submit it, I'll probably get an error. Let's see. Yeah, as expected. So in this situation, you can see there are 3 3 3 3. There are 4 threes, right? But we are just checking for the first threes. So what will happen is that it will return the threes 2 times, because for this first 3, the first lead is this and the second lead is this. So the first one will be there in the answer. Now for the second one, the second 3, now we will compare the second 3. For this particular item, this first lead is 3 and the second lead is again 3. But in our question description, if you read carefully, find all the numbers that appear at least 3 times, at least. So we can't repeat the same number in the answer if it is appearing continuously. So to solve this particular issue, we can just simply apply a distinct here, so it will only get the distinct answers, and we are really free to submit it again, and hopefully this time it works. Yeah, it worked just as expected. So yeah, that's how we can use window functions to simplify our lives. Now let's hop onto the solutions tab and see how other people have done it. Okay, someone has used lag, I see. We can use lag in a similar fashion. We are getting the next items, but this guy is getting the previous items. Either solution works. Now there's something called simple condition checks. So this guy here has done something like a cross join over the 3 different tables and compared them together. But what I believe is this particular cross join practice is not really good at all, because this might cause unnecessary duplicates and a lot of confusion in production scenarios. You rather stick to window functions than doing cross joins like these. These are totally not recommended and not even optimized. Let's see if there are any comments. No comments. Okay, I guess most of them are using lead lag. Oh yeah, here we see a different approach using row numbers. Let's see. So this guy here has created a CTE using a window function. That's a great usage. So he assigned a row number to each each log partitioned by number and ordered by ID. Okay, and then distinct num. Okay, this is some advanced implementation of this problem. You don't need to go to this much complexity. If you want, you can understand this whole solution. I mean, you can go to LeetCode and go to Solutions tab, and there are a lot of similar solutions to this, and you can go through them and understand how they work. But you don't need to know everything, right, for the interviews or even your practical use cases. Even the basic knowledge, and when your basics are clear, everything works turns out just fine. So yeah, but it is really recommended to hop onto Solutions tab and try to understand each one of the situations that other people are like coming up with. Okay, now let's hop on to the next problem and let's see what it has to say. So the next problem is called department highest salary. So here we have 2 tables. One is employee with the columns ID, name, salary, and department ID, and then there is department with ID and name. And this department ID is supposed to be a foreign key to the ID of the department table. Now we have to write a solution to find employees who have the highest salary in each of the departments. Okay, it is similar problem to the group by problem we did earlier, where we grouped all these departments. We would have grouped all these departments together and try to find the highest salary. But here the things are a little different, because right now we are dealing with window functions, right? So we are going to solve it using window functions only. So you can see the input and output formats. We have the employee table as input, and the department table, and the output is in this format. Okay, so let's think about how we can go about solving this. The thing that comes to my mind is dense rank, as we just talked about dense rank a while ago. So let's try to use dense rank to find out the highest salary among each department. So how can we do that? We can do something like select. We can use dense rank over some data, and we'll call it rank from employee table is E. I guess let's focus on dense rank now. Sorry, over. We can partition by department IDs directly, so we'll do that. Partition by E dot department ID. Okay, and we will also order by E dot salary, because we need the highest salary at top. We'll do a descending order by on salary while partitioning it. So the ranks apply in that particular order. The highest will be ranked as 1, and the lowest will be ranked as the the lowest number possible within each department, as we had talked earlier, that it restarts when we split the table into multiple virtual blocks. It restarts the count within each when we get to each new partition within our table. So yeah, that's how we created a rank here. Now let's run it. It will probably cause some errors, and because this is not the final answer, we are just checking if we are doing everything right. Actually, we should print the whole table so we get the idea. Yeah, so the table we got as output is ID, name, salary, department ID, and as well as rank. So if you notice, within each department ID, department IDs are now partitioned. Each department is a partition in itself, and within that partition we are ordering by the salary. The highest salaries at the top within each department. Okay, amazing. So, and each salary has been given a rank. The highest salary has the highest the topmost rank 1, and then there are following ranks, and it repeats after each partition. Perfect. Now this is not enough to solve the solution. Again, we'll wrap it inside a subquery. Subqueries are really handy, man. So yeah, let me format it a little bit. Yeah, that should do it. So now let's try to complete the outer query. We'll select from this particular something. Actually, we'll do department as D, and we'll join this subquery with an alias as let's call it E on E dot department ID equals D dot ID. Is that it? Yeah, that seems right. Yeah, so now that we have this intact, we can apply the condition that we want the E dot rank to be equal to 1, because the first rank will be the highest salary among each department, right? So we can filter by rank equals 1. That will give us the topmost salary. Now we need to specify the output format. So the first thing we need is a D dot name, that is department name, as department. Then we have E dot name as employee, and E dot salary as salary. I hope this works just as expected. Let's see. Yeah, the test case got accepted, and if I run this whole solution, yeah, it works. Perfect. So I hope you understood the logic behind what I just did. I basically splitted each department into a different partition and applied a dense rank ordered by salary in a descending order, where the highest salary would get the highest rank. And then I filtered by I filtered the topmost rank, so I get the highest salary among each department, and I just selected all the appropriate rows. That's it. It was a pretty simple solution, and you get the idea why window functions are handy and why they are important. These topics are more than enough to ace your interviews and understand complex issues in SQL. Now you don't need to spend weeks mastering SQL. A few days is more than enough, and you can actually be practically good if you grind for just a single day on SQL. Keeping these topics in mind, there is more to SQL, just more than just what I taught. But I'll link some problems, some LeetCode problems in the description. If you solve them, your doubts will be mostly clear, and you'll be actually really good at SQL in your practical use cases, and you can literally ace your interviews in just a single day if you grind hard enough. So now that we have understood everything from the ground basics to a little bit advanced SQL that can be used in practical scenarios and in interviews, there is something that is more important than SQL itself. That is understanding database and query optimizations. Now, SQL is like a language to query data. And what is more important than that data is the actual architecture that goes behind that data, right? That handles that data. So just like when we write code, we think about architecture at a higher level, right? We talk about caches, we talk about how should we set out microservices, and how should we improve the code base itself, how to optimize algorithms. In a similar way, we should talk about SQL and database as well, and that is what is much more important in interviews as in practical life too. So beyond SQL, you should know and talk about databases and query optimizations, and that's what I'm gonna do. So let's start the discussion by a little bit of SQL optimization. Okay, so let's start with optimizing this basic query. Now you'll ask me, what is there to optimize? Actually, there is. In this query, we are trying to select each and every column there is in orders table, right? But that is absolutely bad. If you know the columns that you want to use, you should explicitly mention the column names that you want to pick. You just can't use star everywhere unless and until you really want to select all the columns. That is an absolute bad practice in SQL. You should explicitly specify if you want the order ID, you want the amount, or you want the item name maybe. And this is way better because this reduces the amount of memory required for the operation to work. So first optimizations to take care of is not using star unnecessarily. Okay, so let's move on to the next one. Now look at this particular query that I have here. What do you think could be optimized in this one now? Now if you look at the order date, it has been wrapped within this year function here. Now that is again unnecessary. We should avoid usually doing these operations because this significantly slows down the operation. We can rather do something like we use order date as from 01/01/2024 to order date is less than actually greater than equal to, and order date is less than equal to we have 31/0/0 actually 1/2/2024. Now this is far better if you when it comes to optimization, because when you use a column name within a function, the function has its own operations to perform over that particular column. That increases the amount of operation time, right? Now on to the next one. Here we have something called there is a query which might not be familiar, because this is not a typical query that you use to create some data or fetch some data. This is a indexing query. So what are indexes? First of all, when we try to select something or perform an operation using SQL on some data, it iterates through each and every row, but we want the operation to be much more optimal, much more faster. So SQL offers relational databases in general offer something called as an index. Now what is an index? Index is an operation that connects a B tree. B tree is a data structure that relational databases like SQL use in the background to keep the data in touch. So whenever you query some particular data, it looks up in the B tree and fetches it for you. It is much more faster than iterating over each and every element. So it is much more optimal. So that is what indexing is. So you can apply indexes over some particular columns to make them faster. But there is an cost to applying indexes. When you apply indexes to a particular column, the write operations become much more slower, because there comes a cost to it. Whenever you do a new write, an index needs to be applied to that particular entry as well, right? So it should be avoided to apply indexes everywhere, only on the necessary columns where the lookups are needed. For example, like the statuses or IDs, or maybe amounts or dates. On these columns, indexes are usually preferable, but you can't just go around applying it everywhere. It actually depends on the business use case, and the usual use case that you are dealing with. You can't randomly apply indexes everywhere. Now there are a few things that you need to know about indexes. That the primary keys that you apply, not apply to be exact, when you create a table there is a primary key, right? So on that primary key you don't need to explicitly apply an index, because an index automatically exists when you create a primary key for that particular column. And similarly for columns with unique values, you don't again need to apply indexes. With a column having unique values, like if you explicitly mark that column is unique, you automatically apply an index to it. The unique columns always have an index. Similar, the unique query is similar to this index query. You can look it up. So yeah, indexing is a way to optimize your databases by a significant amount. It can do magic. Okay, let's head on to the next one. Now look at these two queries. Which one do you think is better? I mean, I have highlighted the bottom one as green, so you obviously know the bottom one is better. But why? So in the above query, we are using the in keyword, and in the bottom query, we are using the exist keyword. The exist keyword is actually much more optimal to use in a production scenarios rather than the in keyword. Actually, in should be avoided usually. Why? Because when you apply in keyword over an operation where we are comparing some IDs or something, it can iterate over the whole array, even if it finds a output. But with exists, once it once a comparison is done, we have an ID, we want to compare it to something, and the comparison is successful, the query will stop and give out the result. It won't iterate even further. But with in it keeps on iterating until the last row. That's why it is much more preferable to use exist. You can see the syntax that we usually use with the exist query. We are selecting one from orders, where the order, the customer ID within the order table matches the customer ID in the customers table. Okay, this query might be looking a little complex, but it really is not. It's just a matter of practice. Okay, now on to the next one. So select distinct customer ID from orders. Now you must be thinking there is nothing wrong with this query, and that is true until and unless you don't really want the distinct customer IDs. Usually the distinct keyword should be avoided because it has a heavy cost to it. Because when you use this distinct keyword, it actually iterates over each of the row and looks for matches. It has to actually compare multiple data of the same column on multiple columns to look for unique items and list them down. That's why distinct can become costly at times. Now look at this one. Here we are using select star from orders, although we should specify the columns. Let's say we need to fetch all the columns for this particular scenario. Ordered by amount in descending order, and we have limited it to 10 rows. Okay, why is this an optimal query? Because we have used a limit clause here, so we have limited the rows to 10. Now that alone does a lot of optimization. You won't be iterating over all the columns in all the rows in a table. So using limit wherever it is appropriate is recommended. For example, like whenever you are writing an API to fetch a list of something, you should typically use pagination, and pagination relies on this limit offset logic, or sometimes even cursor based pagination is implemented. You should look up what is cursor based pagination. It is a really amazing topic to study about. And limit and offset is something that alone does a lot of optimization. So it is recommended to usually use limits and offsets. Now now this particular query, you can see we have a select query here where we are selecting something from orders where customer ID equals 1. Now what is the explain keyword here? So this explain keyword is actually a very helpful keyword when it comes to optimization analysis. So if you want to understand how your query is going to execute, what parts of the query runs first and what is optimized and what is unoptimized, you can run an explain command over it, and it will give out all the details of this query. How will it run this particular query? It won't actually run the query, but it will actually show a blueprint of how it's going to run the query. Now there is another keyword called explain analyze, which will actually run the query as well, also giving the blueprint of how it ran the query. So these both keywords are really important to understand. If you are dealing with SQL optimization, you should study about it. Then we have these two queries here. So what is the difference between these two queries is that here in the first query we are using a subquery, right? We are selecting all the customer IDs from orders and comparing them to the customer IDs in customer table. So basically figuring out how many customers have ordered something, right? But in the bottom query, we are rather relying on joins than the subquery, and also the distinct keyword. Now, it is usually recommended that you use joins instead of subqueries, because joins is much more optimized way of fetching tables, because it literally takes it from the storage and lays it down in the memory. Meanwhile, when you use subqueries, it is built at the runtime, and which causes a lot of overhead, and it is bad for the performance. So it is rather recommended that you use from and join along with in your queries. Then let's talk about a topic called normalization. I won't go very deep in this rabbit hole, because this is a really deep concept to study. There is a lot of variations with normalization. At the very basic level, the concept of normalization is to avoid a duplication of things and keeping things clean. Like, let's say we create multiple tables, right? We have orders table and customers table. Now we usually use foreign keys for referencing data, but if we not do the referencing, and instead save the same data in different tables, like for customer data and orders data, what if we store the names twice? Whenever a customer places an order, we save the name instead of the ID. That will create a redundancy in your databases, which is an absolute bad design. What if the user changes its name, right? That will cause an havoc in the system. Or let's say you want to reference more details about the particular user. You can't do that with just the name. You can actually, but that would be a lot more slower. Now, normalization is a gift when it comes to databases, but there is another concept that is actually quite the opposite of normalization, called the denormalization, which is again sometimes preferable, like in systems where huge amount of data is being processed, like a social media application like Facebook. Do you think they store normalized data? Yeah, they definitely do, but they also keep a denormalized copy of their data. Why so? Because processing each data every time is a heavy procedure, and it will lead to performance degradation. So these big companies or big organizations with huge databases usually denormalize their data to give you a shallow copy of the data that they already have, instead of processing it again and again. It works like a semi cache. Although the throughput of the database is low, it still is sometimes recommended to denormalize the data. Now comes the final topic, not exactly a topic, but a point of discussion, that SQL performance is mostly about reducing the amount of data processed. So yeah, whenever you are writing an SQL query, think about iterations. Think about how many rows, how many columns are being drawn into the memory or being computed, because that will allow you to think how should I, or what is the best approach to solving this particular data query. Because the performance of an SQL query hugely depends on the data being processed, how it is being processed, and how long it will take to process, or how much memory are we utilizing. So yeah, that is actually more than enough for a one-day prep. Now it's your turn to practice it more, solve more LeetCode problems, understand the concepts even more deeper, talk to LLM, search online articles, and study about databases and SQL queries, optimizations, and how to use these scenarios practically. That is how you ace the interviews in a single day, and also be practically good at writing SQL queries in your day-to-day life. And yeah, that is it. That's all I wanted to talk about through this video. Thanks, and bye bye till next time.